So we found for A that this changed. So when we changed the speed of the magnet, it changed how much EMF there was. And when we changed the pole of the magnet, you said it changed the direction, but not necessarily how much there was, right? Okay, so this changed the direction of the EMF. And direction is kind of a misnomer. What we're really talking about is the direction the current travels, which is basically from positive to negative, what you would expect normally, or from negative to positive, depending. So pole's changing the direction, speed is changing the speed. Okay, so nothing weird there. All right, let's go on to the next one. Mike, what about your group? What did you guys notice about inserting versus removing the magnet?
When inserting, the needle went to the right, and when removing, it went to the left.
Good. So this one is another one that's a direction. This is another one that's going to be, that is not what I thought this was. There we go. So this is another one that changes the direction of the EMF. Okay? And again, doesn't really affect the overall amount. Okay? If it did look like it affected the amount, it's because you probably inserted or removed it at a different speed. But doesn't seem to affect that too much. 4 is a tricky one. So what you should have found is that for 4, it does have an effect if you put it in versus through the middle or through the outside. It's just going to be a much smaller effect, and it's actually going to be in the opposite direction. Let me show you this one. This will be a little easier to see this way. Okay, so if I insert it into the middle, you can see, I'm glad it has sound effects. That's super helpful. Okay, so when I insert it, you can see the effect is fairly large. When I go on the outside edge, notice that it still has an effect, but notice that the effect is very small and in the opposite direction. Okay? Sorry, making a note to myself. All right, and then the last one. Devin, what about 5? What did you guys notice about the number of loops, how that seemed to matter?
The bigger the coil, the slower the needle went, and the smaller the coil, the faster the needle.
Okay, so you would have noticed an amount of it, and that has to do with kind of the effect. What about overall size of the effect? Anyone notice a size effect, Mike?
More coils, more dramatic.
Yeah, so the number of coils should have an effect on how much EMF there is. All right, so let's look at the 3 things that we should have concluded from this. So we want to figure out directly or inversely proportional to the rate of change, or what effect overall does it have. So for test 1, we found that, so you guys mentioned that when you did it at different speeds, the faster the speed, the more EMF was induced. Well, larger speed means a shorter time. So we're talking about rate of change. So that means that in shorter amounts of time, you generate larger EMFs. That means it is inversely proportional. That one's kind of tricky because if you think of it as speed, the faster speed has a larger amount. That seems direct. But the equation, the reason I'm saying it this way is I know what the equation is, and the equation does not have speed, it has time. Okay? So time is inversely proportional. So, and the effect was basically affected the strength of EMF. Two is tricky because for the ones we tested for 2, it didn't really look like they had an effect on how much EMF there was, right? When we inserted it versus removing it, that changed the direction. When we did the pull of the magnet, that changed the direction. The one that kind of gave us a little bit of a hint is this one. When we put it in through the outside versus in through the middle. And we noticed that basically when the magnet went on the outside, less magnet is, well, I guess I should say fields. Less magnetic field is going into it. You can see it in this diagram much better. Notice that when I insert it into the middle, look how much field goes in. There's a large amount of field that travels through that wire. When I push it on the outside, it's half the field going through. So there is still an amount of field going through, but it's a lot less. So, yeah. And that's because when you insert it into the middle, you get both the field that curves up and the field that curves down. When you insert it on the outside, you get only the field that curves down. So, for these tests here, describe the effect and tell me whether you think they're directly or inversely proportional. So they are going to be directly proportional. The more field you have, the more EMF there is. And this one, at least for what we did, seemed to have mostly an effect on the direction. Direct in, good. Direction, mostly, for what we were testing at least, and then strength, some. Okay, and then last we had the number of loops. So what do we notice about the number of loops? Marcus, when you guys were testing number of loops, what effect did we seem to have? Oh, we already talked about that one. This one, we noticed that when they had more loops, we said this already, more loops had more induction, and so this is directly proportional. And it is mostly going to affect the strength. There you go. All right. Questions on what's going on here? All right. Keep the lab out. Switch back to the notes, okay? So switch back to the notes. Either go back to your notebook or go back to where you had it on your computer, but we're going to switch back to the notes now.
I didn't hear any sound when I was entering the song.
I know.
It must have been
disappointing. I know. Because clearly from the lab we know that it makes magical humming angel noises whenever you do it. All right, let's jump back into the notes here.
What if you had coils around the coils?
You mean, what if you had this? It just depends on how you go through it. But they affect each other a little bit differently.
So with the stacked one, what does stacking do?
This?
Yeah.
It's not stacked, it's just two different ones. They just happen to be next to each other so you can test them together. All right, number 4. All right, what 3 things... We've already talked about what 3 things. What we haven't talked about yet is why. So we've talked about the 3 things, and the 3 things are magnetic flux, number of loops, and rate of change for magnetic field. Okay, so there are the 3 things. Those are literally just straight off the lab that we did. All right, so the question is, why do each of these things matter? So we defined electromagnetic induction to be basically when we have a changing magnetic field causing an induced voltage, okay, an induced EMF. So why would magnetic flux matter? Well, magnetic flux is how much field goes through a loop of wire. Basically, the more field that goes through, the larger the change, which means the larger EMF. So the reason why magnetic flux matters is because it affects how much magnetic field. Remember, B is the symbol for magnetic field. How much B goes through the loop. So, the more field you have going through, the larger the effect is going to be. All right, so why does the number of loops matter? Well, the number of loops matters because it basically multiplies the effect. So if you have a certain amount of magnetic flux through one wire, if you have it through 2, it's double. If you have it 3, it's triple. And basically, you're just increasing how many times this effect happens. So it increases the number of inductions. Okay? So the more loops you have, the more times this flux change happens. Okay? And lastly, the rate of change for the field. So why does rate of change matter? Rate of change matters because so we said that EMF is based off of the changing magnetic field. So the rate of change determines how much change happens and how quickly. So the reason rate of change matters is it basically determines amount of change that happens. It determines how much change there is. So magnetic flux is the amount of field. The number of loops is the amount of times that field change happens. And the rate of change is how much change there actually ends up with. All right, I'll give you a second more to make sure you have each of those 3 things. Because this is really important to just understand basically what are the 3 things. Okay? And those are the things directly from the lab. Magnetic flux, which was all that stuff we were changing about, like the polarity and how much and that sort of thing. The rate of change, how quickly we did this, and then the number of loops that were